Hi, welcome back to Math 111 online through Blue Mountain Community College. Today I want to spend just a couple of minutes. Let me see if I can make that do a couple of things a little different here. That's better. Now let's get it in focus. There we go. Okay. So we are going to talk about section 6.2, which is all about inverse functions. Now, this is really just a fancy way of saying reverse operations. So what the inverse of a function does is it essentially reverses the action of that function, or sometimes we say it undoes a function. So for example, f of x equal x to the third power. The inverse of f, which we sometimes write as f inverse. So that -1 exponent is just a fancy way of saying inverse. You know what undoes x to the third. It's the cube root of x. Another way of thinking of this is that if you start, say, at home, and you walk to Joe's house, let's say you walk down the sidewalks, no shortcuts. All right, to get to Joe's house, you walk a block east and then a block south. That's the forward action. That is the function. Now get home, you reverse that and you walk a block north and then a block west. Going to Joe's house is like the function. Going home when you reversed your path is like the inverse. So the inverse of a function reverses that function. Now I want to talk to you a little bit about the relationship between an inverse and a function as far as the domain and the range go. So this one's way too boring, but it'll work. So let's look at this cubic that I talked about that I drew a minute ago, or talked about rather. If I graph this thing, it's not very exciting, but it works. It's just this kind of flat, stretched out S shape, right? That's the function. Now, if I were to graph its inverse, so cube root of 8 is 2. So its inverse goes this way. Now here's the thing. When you graph a function and its inverse like I just did, if you draw very carefully, we'll see how carefully I drew, not too bad, you will have a line of symmetry along this diagonal line. This diagonal line is actually the line y equals x. And it forms a mirror plane between a function and its inverse. In other words, if I mirror this point on the function across that plane to that point, if this is, say, 2, 8, then the corresponding point on the inverse will be 8, 2. The x's and the y's are reversed. What that means is that the domain of the function corresponds to the range of the inverse. And the range of the inverse corresponds to the domain of the function. Remember that the domain are the x values that we are allowed to put into a function. And the range is the set of all y values that we can get out of that function. Okay, so that's the basics of what a function inverse function is. Let's talk about how we find them. It's pretty simple. To find the inverse of a function, the easiest way to do this is for me to show you. Let's find the inverse of the cube root. So let's say y, my function is y equals x to the third power. To find the inverse, reverse x and y. So write x equals y to the third. And then solve that for y. And you will get cube root x equals y. This is the inverse function. So if your function is f of x equals x to the third power, your inverse function is cube root of x. Now, this inverse, and it is a function. Not all inverses will be functions. Let's look at another example. Let's suppose f of x equals x squared. And I want to find the inverse. First thing I do is I write it in y equals form. So write y equals x squared. Now I swap x and y, and I get x equals y squared. Now I'm going to solve for y. And I'm going to remember that if I take the square root of both sides, I have to take the positive and negative square root. So what happens here is my function is this parabola. The inverse is this sideways parabola. Yeah, we'll call it. We'll do this. I'm not using function notation because this is not a function. So if you have to use a plus or a minus when you're solving for y, then your inverse is not a function. If, however, you can solve like this, and you don't end up with anything funky like a plus or a minus, then the inverse is a function. Functions whose inverses are also functions, like this one. Let me write this down. Functions whose inverses are also functions have a special name. It's a 1-to-1 function. And all that means is that the inverse is also a function, just like the function was a function. All right, so let's do a little practicing here. Let's do one more example. Let's find the inverse of the function g of x equals x minus 4 over x minus 2. Now we already know some things about this, right? We've graphed these before, so we know there's a horizontal asymptote at x equals 2. So I want to graph this thing. I know that it has a horizontal asymptote at, y equals 2. Y equals 1, because my degrees are equal. And a vertical asymptote at x equals 2, because we can never have a 0 on the bottom of a fraction. We could graph a couple of points and we would get this basic shape for my function g. Now, based on what I told you a minute ago, you might be thinking to yourself, well, if I swap, well, let's just graph this thing. Let's just do this and see what we get. So first thing I'm going to do is write it in y equals form. This is my function. Now I'm going to swap my x's and y's. Everywhere I see a y, I write an x. Everywhere I see an x, I write a y. Now I have to solve this guy for a y. So let's multiply both sides by y minus 2. Distribute through my x on the left. Pull my y's to the left and any x that doesn't have a y with it to the right. So I end up with x times y minus y equals 2x minus 4. Factor out the y on the left. And we end up with y equals 2x minus 4 over x minus 1. Okay, let's think about this guy for a minute. He has a vertical asymptote at x equals 1. The horizontal asymptote, because the degrees are equal, is at the ratio of the leading coefficients. So we got a horizontal asymptote at y equals 2. Okay, so here's what I want you to notice. We've got an x equals 2 and a y equals 2. This one's the function. This is the inverse. What was y is now x. What was x is now y. Okay? Keep that in mind. Function inverses reverse x and y. That means that the domains and their ranges also reverse. All right, I hope this helps. That's pretty much all there is to inverse functions. Important things to remember. The domain and the range flop, so the domain of the function is the range of the inverse, and the range of the function is the domain of the inverse. If you graph a function and its inverse on the same set of axes, you should see symmetry across this x equals y line. And to find inverses, you simply reverse x and y, and then solve for y. All right. Everybody have a great day, and I will see you again soon.